Yes, ma, we can see the screen.
Can you proceed the one I said last time? I know you people, I don't know whether you are in inventory, whether you people read what I said, because there are some mistakes that it might confuse you people. I just want to go back to clarify you people so that you won't make mistake. Are you getting what I'm saying? In this place, economic order quantity, the last thing I taught you people. Let me just go back to it. Okay, under fix. You know, I taught you people about inventory last week. This question, economic order quantity, the one we solved. This question, there is a little mistake. So I don't want you to get confused when you are solving it. This question, question 1. You know, there is mistake there. So I want to clarify. Good. Under optimal order quantity, you know the formula, which is economic order quantity. The formula is 2 times the annual demand times the ordering cost, which is X, all over holding cost. All of them will be in square roots, because I just noticed it. I say you people might be confused. All of them will be in square roots. Then, even there is mistake here. When you say 2 times the annual demand, they use average daily demand. This 1,000 over 365, which is wrong. What you will use is annual demand, which the question is, the annual demand given is, let me go back. The annual demand given is 1,000. It is only 1,000, but they use 1,000 over 365. Even as they use this, they are right in the answer, but what they fix is wrong. Because if you solve it, you will be confused and you will say, how did they arrive at that answer? But they are wrong, because they use the wrong thing, because the developer make a mistake. That's why I want to clarify you people. So you use annual demand, which is 1,000. Then the ordering cost, which is S, which is 5,000. Then the holding cost, which is H, 1,025. So when you substitute it now, you say 2 times 1,000, not 1,000 over 365. This 365, you use it and solve the average daily demand. When you want to determine the reorder level, that is when you will use it. So for this economic order quantity, you are determining the quantity that you will buy when the reorder level reach. You know, that is what you are determining. If you recall what I taught you last week, I said this economic order quantity, meaning the quantity that you will buy when the reorder level has reached, which is 2 times 1,000, not 1,000 over 365. They made a mistake. Times 5, all over 1 point. When you solve it, you will get 800, maybe 800. Then square root of that, you arrive at 89 point something, which we around, that's what you will now arrive at 89 units. So what they solve here, they are wrong. But that's why I say, if I'm teaching, just listen, know the formula. Once you know the formula, you will now substitute. Forgetting don't look at the answer. That's what I want to clarify you, because you'll be confused. The formula is 2 times the annual demand times the ordering cost, all over holding cost. All of them will be in square roots. So that's what I want to clarify you people. Then when you get it, it will now be 89 units. That is the quantity that you will buy more when the reorder level reach. Then what you now want to know the reorder level, the level that it will reach before you now buy this quantity. The formula is D times L, which means the average daily demand. That is now when you will use this 1,000 all over 365 times the lead time, the days that we used to. When you solve it, you will arrive at 13 point this thing. That's when you now proceed, it will now be 14 units, which shows that when the thing is the level reach to 14 units, you now place an order for 89 units more. Then if you don't want to get the total cost, which is equals to the demand times cost per unit, times annual distance, times the ordering cost, times quantity, the quantity that you get, which is 89, times the holding cost, all over. Because this thing, they made a mistake. This thing is supposed to total cost equals to, this quantity will come here, all over the quantity, and 2 will be here. So there's a mistake. This quantity that is here is not supposed to be here. This over is not, this total cost is supposed to be independent. It is on its own. I just want to clarify because the developer, he made a lot of mistakes so that you will know. In case of tomorrow, you say, what is this? So see how the place the thing is separated, how it's separated now. When you say total cost equals to the demand, which is 1,000, times the cost, which is this, plus this, the same demand, 1,000 times the ordering cost, plus the quantity, this is clear. That quantity that you order more, times the holding cost. Because you want to know the total cost, what it will cost you. Then when you solve it, you arrive at this. I just want to clarify you because I know when you are reading it, you might get confused and say, how is this formula like this? So that is what I want to clarify. So this one is when you are adding both a product and this thing. That is the total order quantities. This is 2 times DS all over H times P all over P minus average daily demand. All of them will be in square roots. You know, this is a mistake. See how they draw this thing. Everything will be in square roots. So that's what I want to clarify you so that you won't be having mistake. Because when you are solving this second one now, you will now see what I say. You substitute it well. See how it is. You now substitute it using what I explained in the first instance. So let's go and do what we have today. We are going to do correlation analysis today. That is the topic we have today. I just want to classify because I know some of you get confused when solving it because of the mistakes. That's what I want to show you. So what is correlation analysis? Correlation analysis is just a technique that shows different two variables. That's X and Y. X and Y variable. What does it mean? That's the relationship between the X variable and Y variable, which shows that when S, to know whether if S is increasing, whether Y will also be increasing. That is the relationship between the S and variable, which is two variables, meaning that when one relationship, whether one will be increasing and the other one will also increase. Let's just give you an example as maybe a year as a farmer, when he harvests his product, maybe yam, and the quantity of yam, when you look at the quantity of yam, let's say the quantity of yam represents Y, you now compare it with the quantity of maybe fertilizer that the farmer used in cultivating that yam, which will be Y. You now check whether it is the same quantity that the product yield. Is it the same quantity that being used in cultivating that product, which is Y, which represents fertilizer? That's what I'm trying to say now. Then you can also say, okay, let's use a student, for example. The relationship of students capacity in class, maybe his performance. Let's check that a student is performing well. You now, that student presents X, and you now say, okay, let you know the relationship with his background, that student background, whether maybe it's because he came from a, that person should mute his or herself. The person is disturbing me. I don't know that person. Somebody is disturbing me in this. Mute yourself. Let me talk, please. You now know the relationship between that student performance and maybe his background. Maybe the student came from a good background where he has every facility. Maybe when he go, he continue reading and everything. And he eat good food, you know. You now check the relationship. That is what we are trying to say in this thing. Correlation is just between two variables, S and Y. Knowing whether when one is increasing, whether the other one is also increasing. Then another one, when one is increasing, whether the other one is decreasing. Or when the two of them, they don't even have direction, which we call that one scatter this thing. When you, all these things I'm explaining, it means that correlation have three types. There's one you say positive correlation. That is positive relationship. The one we have negative relationship. And we have the one we have zero relationship. Let me explain it. When you have positive relationship, it means that when S variable is increasing, Y variable is also increasing. Then negative relationship means that if S variable is increasing, Y variable will be decreasing. And zero relationship means that both the two has no pattern of direction. That is, if you're putting it in a graph now, that one normally have scattered diagram because it doesn't have direction. When you have zero relationship, there is no direction. But when you have positive relationship, mean that all of them is going at the same simultaneously. When one is increasing, the other one is increasing. When you know what simultaneously happen at the same time. Then if it's negative relationship, mean that when one is increasing, let me even ask a question. Hey, maybe when I'm about to finish, I will still ask this question. You know, the religion is increasing in this one. Whether this religion, there is the number of religion we have now, all these churches we have, whether it relates with the righteousness of people. If you look at it, as this church is increasing, the righteousness is even decreasing. Because as it increases, we have many churches now. That is even when bad thing is happening. A lot of evil thing. I don't know whether it's this church, as is this religious, if this thing is increasing, you even have bad people, which means that righteousness is decreasing. Have you seen it? It's have a negative relationship. That is what we are trying to say. And this correlation have two types. We have one of Pearson product moment correlation, and we have the one of Spearman rank correlation. I will explain. Let me use this thing too. They have correlation coefficient. Correlation coefficient, you use R as the coefficient of this correlation. And let me tell you, correlation can be more than one. It is one. It ranges between -1 to +1. That is how correlation ranges. It ranges from -1 to +1. When it's -1, it means that when it ranges, that's close to, when you, after solving the coefficient of R, and maybe you get -0.889, which means it's close to 1, but is negative. What we now present is that it has a strong negative relationship. But when it is plus, it has a strong positive relationship. Just know that if after solving and R, coefficient of R is more than 1, it's know that you are wrong, because it can be more than 1. It ranges between -1 to +1. And when it's closer to 1, it means it has a very strong relationship. But when it's less than 5, it has a weak relationship. When it's from more than 5 to close to, that is, sorry, 0. Like, if it is 0.4 something, it means it has a weak relationship. But when it's 0.5 up, the relationship, it means that the relationship is stronger, is strong. But when it is maybe 0.89 something, it has a stronger relationship. But when it's from 0.43 down, it has a weak relationship. Don't worry, when we are solving, you understand me. I want to explain before we go further. So the formula for getting that L coefficient is N meaning the number of weeks, or depending on what you want to use, times summation of SY. SY means the two variable of X and Y variable, minus summation of X times summation of Y, all over square root of N times summation of S square minus X, summation of S in bracket square, times the number. Just this is the formula. So when we are solving now, you understand what I mean by this, because after everything, you now substitute it in this formula to get your coefficient of R. When you get the R, that is when you now determine, this formula is the formula for Pearson product moment correlation coefficient, which I say it is 2 types. We have the Pearson product moment coefficient, which is made for by Karl Marx. Is the Karl Marx that developed this Pearson product moment correlation. Then we have the one of Spearman rank correlation. When we finish this one, we do the Spearman rank correlation. So this is the formula for Pearson product moment correlation, which is you use R as the coefficient. So when you get the R coefficient, that is when you now determine whether it has a strong relationship or a weak relationship. And again, whether it has a negative relationship or a positive relationship. When you now get the R coefficient. So assuming you are given this question now, this question, let me not read because you are seeing it. This is cell representative. All these people are cell representative. James, John, Peter, Paul, Bola, and cell call for S is this, which is computer sold for Y is this. This is one variable for S. This is another variable for Y. When James, this means that James for cell call for S is 20, and this one is that. Just assuming you are giving that question, what will you do? You first of all, when you do that, you will now have this table. You will now get S times Y variable column. You also get S square column and Y square column, because all this column will help you to get all those coefficients that you will now, all those symbols that you will now substitute to get your R coefficient, because that's what you determine. So this is what you now determine using this thing. First of all, you say S times Y, which is 20 times 30, you get 600. Then you now determine S square and Y square. S square means this for 20 square, which is 400. 10 square, 100. That is where you get all the square. Then Y square, 30 square will give you 900. When you times this one, that's S times Y, where you now get all these things. Then when you now get it, you now say, this one is, all this thing is summation of X. This is summation of S. And N is 1, 2, 3, 4, 5, 6. N, to determine N, there are 6 in number, which is 1, 2, 3, 4, 5, 6. That is your N. This one, N is 6. Then when you now want to get your summation of X, summation of S meaning you add all these things. That is summation of S. 20 plus 10 plus this plus this plus this. which will arrive at 105. Then summation SY, which is all this in summit. Summation of S square, you now solve all this, you get it. Summation of this, you get it. So you now substitute it to get your R, which is this formula, which is N, which I say N is 6. And the summation of SY is, which is 4,800, which is what you get, minus summation of S is 105, times summation of Y is this, all over square root of N is 6. Summation of S square is this, minus summation of S, you now square it. You know, summation of S is 105, then you square it. Then N is this, summation of S, Y is this, minus summation of Y, you square it. When you, after solving everything, you arrive at this. After solving Bobotibo, when you go, after this, you solve it yourself and know whether you arrived at this. You will now arrive at R is 0.88, which is, it has a, is positive and is closer to 1. It is, you know, when I say, when it's 0.5 up, it means when it has a strong relationship. And you can see R is plus, it is not minus. That means it has a strong positive relationship. That is what is significant. That is the significance of this. It has a strong positive relationship. That is what it means. And it's close to 1 because 0.88 is very close to 1. It has a strong negative rate, which means that when you 80% of it. And when you determine the coefficient, sorry, the coefficient, which means that 0 point this, you square it. When you square it, you arrive at 0 point this. Then when you say, when you want to 77.57%, that's the coefficient of determination. Knowing that determining the coefficient of determination, meaning squaring that R. When you square it, you now determine normally 0.05. Then testing for this thing, they have different rules when you want to test it, which means it's the same thing as testing the hypothesis. And you know, let me tell you what hypothesis means. Hypothesis is all about guessing. You are guessing idea for that will help you to solve your problem. That is the idea. Guessing. You say hypothesis. You are guessing. Assuming now, let me use an example to explain very well what hypothesis is. I know most of you might know what it means, but let me still explain it. Assuming you are driving and you are driving and a short time your car just stopped. And you are still inside your car. What will come to your mind is that, what is this? You will start guessing. Is it the fuel has finished? Or is it the plug? You know, you are in your car, you are guessing, what actually made this car to stop? You start saying in your mind now, is it that my fuel has finished? Or is it a plug problem? Is it electrical problem? That is, you are guessing now. All these guess, you put it down. You are saying, is it a plug? That may be the plug that made it. Is it that made it to stop? All lesson car to stop. That is hypothesis. But when you say hypothesis down from your car, when you cannot, you know, maybe you open the bonnet, you start testing all those things that you guessed. You first of all say, okay, you check whether it's fuel. When your fuel is still remaining, you say, and you can now start relationship. Within a relationship means that when I tested it, my car working again. That's its way. That is when you say no hypothesis. It means when you are testing for a scam, all these things that
Hello, madam.
Hello.
Seems the network is is breaking, madam.
Are you with me?
Yes, we are.
Hello.
Hello, I can hear you.
Okay, we can hear you now.
Then another one, you know, say a level of significance, which I say is normally 0.05. Let me after explain all these things. Then you compute the test statistics. What do I mean by test statistics? Because after testing, there's one you call calculated one and tabulated. Tabulated means the one you get from the table. And there's normal, the one they say normal distribution. After you browse normal distribution table, you will see the table. You know what I'm talking about. Then calculated one is the one you solved. Then tabulated one is the one from that table. You will check whether the calculated one is greater than the tabulated one. If the calculated is greater, you know whether to accept or reject. Do you understand? When one is greater, you know it is no hypothesis. And you know when it's not, you now reject the no and accept the alternate. Or if the other one is greater, you now reject the alternate and accept the no. When we solve it now, you see what I'm saying. Then that is the computing the test statistics. Then test statistics normally T is a student test statistic. Is normally when the population is small. And when the population is small, it means you are using all of them. The population will now represent the sample size. That is, but when you are talking of Z, I'm just giving you more knowledge because it's not, when I'm saying Z distribution, it means that the population is big. Do you understand? You can't use all the population, you now determine the sample size. But when you're talking of T, student T distribution, that is when the population is small. When the population is small, you talk of T distribution. That is when the population is less than 30, is not more than 30. If the population is not more than 30, is less than or equals to 30, that is when you know it is T distribution. And it is, you now use it as sample. I'm explaining, then you formulate the decision rule. Decision rule meaning you now decide whether to accept the alternate or no. Well, when you're accepting the alternate, it means you are rejecting the no. But when you're accepting the no, you are rejecting the alternate. Then that is the situation when you let's announce all these things I'm saying. Then as you can see it, stating the no. And when you want to represent HO, an alternate represent H1 or HA. When you see HA, you know it's alternate, but HO normally represent the no. Then I said the level of distribution is normally 0.05. Then if it is Z distribution you are dealing with, you now use the 0.05. That is when it is a 1/3 test. And there's something we call 2/3 test. Is when you now, after you browse that table, the distribution table, they have Z distribution table, they have T distribution table, they have normal distribution table. Browse it and see all those tables. You will see what I mean. When you browse, you see all the tables. Then you will see where they say 1/3 test, 2/3 test. You will see all of them. Then when it's 2/3 test, it means you will split this thing into two, this level of significance, knowing that it is when the population is less than or equals to 30. That is when the level of significance normally represents this thing, this arrow. A, this is something like A, but it's not A, all over 2. You now split this thing. When you split it, it becomes 0.025. Because we are saying the first one now. Then I said before it is T test when the population is N minus, is less than or equal to 30. It is not more than 30. And the degree of freedom is N minus 2. This N meaning the number of, N meaning how many it is. And our N, you know our N is 6, which I said is 6. Then minus 2, that is degree of freedom. When you browse all those things I told you, you will see all these tables. Anyway, you will know it because you did statistics in your under G and this thing. You will know all this thing I'm saying. It's just that I'm trying to refresh your memory, this thing. Then this thing N is 6, which is 6 minus this, which is 4. What does this thing mean now? It means that when you download this T distribution table, which I said it is, when you divide this thing, you see 0.025. It means that under 0.25, when you see, go to it, you will see 0.025. You will see 0.05. You will see 0. All these things. But you under 0.025, you will come down to 4. When you 4, because you know they normally write 1, 0, 1, 2, 3, 4, 5 to maybe 20, 30. Under this thing, you see 1, 2, 3, 4. Because this thing is 4. Under this 0.025, you will come down to 4. When you come down to 4 and look under that 4, you will see it will show you 2.776. That is what you get. After this thing, you download it, check what it's under T distribution. You will see what I am saying. Under this 0.025, under 4, you will get 2.776. And you know how you get it is, you know, because they might give you the one, N might be 8, depending on, because our N here, the one we solve is 6, because there are 6 people, 6 this thing. That is why it's 6 minus 2. You get 4. That is what, if it's 8, you might be 8 minus this, you see 6. It means under it, under 6, you check what is under 6. Anything that you check as under 6 will be what you get. And that one is, that is the calculated, the tabulated one. We call this one tabulated one, the table, because it's on is the table that you find this thing. That is the table I'm telling you. Because I told you they have the calculated one, the one you calculated, and the one the table. That is the table. This is the normal distribution curve. We call this the normal distribution curve. That is where you reject the no. This is no, rejecting. It means that thing is normally, you know, I told you is when on this curve, this thing ranges from -3 to +3. When you download everything, you read about it. You did this thing in statistics. Ranges from -3 to +3. Then you now plot. This is this thing we get. -2 this thing to plus this thing. You know, our own is plus. Assuming you solve and get minus. Then this one is now the compute the test statistics. This is the table one we have found. You now keep it. You now do the calculated one. This is the calculated one you will do. When you finish the calculated one, you now compare it with the tabulated one to know whether you are rejecting or accepting. So the formula for T for the calculated one is R. That is the coefficient of that correlation we got. Square root of n minus 2 all over 1 minus the coefficient of determination, which is this, with n minus 2 degree of freedom. So then you now substitute it. You know, our R is this and our N is this. So T equals to R is this. 6 minus 2 all over 1 minus this. After, when you finally, what you get is 3 point this. Have you seen it? See the decision rule now. It says reject no hypothesis because HO is no. It is less than. Is when it is less than minus this or greater than is this. Do you understand? Do not read. You get it. When you know when is T is less than. When is less than is when it is minus this thing, or is greater than is this. In case if you solve and you get minus, that is why you want to explain. Because if it's minus this, it may is less than. But when it's plus now, it is greater than here now. Or do not reject if otherwise. Otherwise meaning that if the calculated lies between this and this. So the decision now is that since T, which is the calculated, see the calculated. Have you seen now? The calculated is greater than the table one because our calculated is 3.7055 and our table one is 2.776. Have you seen that is greater? Then now that is the decision you are taking now. Since T calculated is greater than the value of T obtained from the table, which I say when you download the T distribution, you will get this thing I said. Then you reject the no. Assuming now, if the table one now is greater than this one we calculated, it means you are not rejecting the no. But since this calculated one is greater than this table one, you now reject the no. Which means when you are rejecting the no, it means you will accept the alternate, which is H1. That is the decision we have made. Because before you do this thing, you state all these things. You see how we started. One is to formulate the null hypothesis and the alternate. Second one is the significant. Third one is the test, calculating the test statistics. The fourth one is formulating the decision rule. Then the final one is the decision itself. Have you seen it? You learn it when you finish. Have you seen how the correlation is being? That is the Spearman rank correlation. At least when you read the Pearson, at least you know. Let's quickly do the Spearman rank correlation. Let me tell you, assuming I think most of you know what Spearman means. Let me just explain. Spearman means ranking is a rank. Let me give you an example now. When you did your project now, you know, reliability test, you normally do reliability test to know how reliable your instrument is, whether it's reliable enough. Because if it's reliable enough, you know that you can use it, that it has a perfect relationship, or it has a positive relation, or it is relationship. You know that it is reliable. You can use it. Assuming you are doing a project now, you are writing maybe dissertation or thesis, and let's say you are using a manufacturing company, or let's say banking industry, to do your this thing. You use it for your questionnaire because you want to get information, data. You want to get data, which is information concerning what you are researching on. And you are using a primary data. You know, when you are using primary data, that is what involves questionnaire, using questionnaire. Because if you are using secondary data, it means you are not using a statistical. You are not using a primary data, which is questionnaire. But if you are using a primary data, it means you are using questionnaire. And you want to, maybe it's banking industry, you are doing a research, maybe in banking industry. Knowing maybe you are doing let's say, change management. Knowing the change management on the performance of deposit money banks, how the performance being when because of the changes that has been occurring in the banking industry. And now we are using 5 banks. Then you want to test the reliability. You know, when you're testing the reliability, meaning that before you do your main sending maybe you're using your sample size is maybe 300. You know, there's something they call pilot study. You want to do pilot study. You're using a portion from that sample size. Maybe you now say, let me do a pilot study. Let me just use 40, do a sample size, that is 40 questionnaire, and maybe send it to these 5 banks and know their responses. Then when I know it, I will not know whether I will, before you now use the main or the sample. Then let you now say, okay, let me now do a portion, like using 40 sample, that is doing 40 questionnaire and send to this bank. Maybe after sending it, they will answer, maybe you are using 5 Likert scale. That is strongly agree, disagree, strongly disagree, or you know, that 5 Likert scale. Then maybe when you return it, maybe those that say strongly agree, maybe they are 30, agree 5, disagree 2, all these things. After 2, you say, okay, let you return the same content of this instrument to know whether they will still answer the same thing. Then maybe when you take it there, after answering, you will come back. That is when you are using Spearman rank correlation. You now rank the 2 and know whether the first one is related, has a relationship with the second one. To know how it is related, how the relationship, whether it has a close relationship. When it has a close relationship, you know it's reliable. That's what they answer in the first step. They still is very close to what they answered the second time you shared it. What they answered the second one is very close to what they answered in the first one. That is when you now rank it and know that it is reliable before you now share the main sample. I just want to explain before we. Let's now go, let me show you example to know how they rank it now. Assuming, let's just use this example now. This is the formula. You know, correlation is normally R, but this is the formula for Spearman rank correlation. The formula is 1 minus 6 summation of D square all over N, you know, bracket N minus, this 6 is constant, N bracket N square minus 1. You know, N is number of data pairs. You know, N is number of, I said 40. Maybe you shared 40. When the number you share is 40, that it represents the N. Then D is the difference between any pair of rank. That's the difference between any pair of rank. Difference between the 1 and 2. That's the formula. After pairing, you use this formula to solve it. anything you now get, you now know how close it is. You know, I told you that correlation is 1. It cannot be more than 1. So after solving and you get more than 1, you know you are not getting it. Let's now do the tie in rank. That's ranking. In the sense that, let's just use this example now. The following item, S this is the first one you share. Let's say that this is X. You have 15, 33, 10. Then this one is 1 and 25. Then X. Then you want to rank it now. You are ranking the one that have the highest number. You rank it 1, followed by the one that followed it. You rank it 2. The other one 3. The other one 4. But the one that has like that occurred 2 times, it will be. I will show you. We still have example of it. You will divide it by 2. When you divide it, you will rank it the same number. Then the other one, you now write it as 3. But we still come to that. But I just want to show you how to rank this thing. Like this S now, they said first one is 15, 33, 10, 10, 12, and 5. So 1 and 25. So you now, first of all, the highest, you rank it as the 5. The highest, you rank it as the highest. You started, the least one is, you put it as 1. Followed, you just be ranking it at is the least. The highest, we take the highest number. So the least now is 1. This is, you rank it as this. Then followed the, okay, let's start from the highest. The highest is, here is 33. 33, you rank it as 3, as 5. Then followed by the second one. So this thing is, yes.
Hello, ma. I think the second one is
12 and 5.
No,
12
they mix this thing. This one is 15. Are you getting it? This one
yes,
is
33.
Okay, this one is 33. Sorry. This one is 10. This
yes,
one
ma.
is 12. And this one is
Yes.
5.
It's 5.
Yes.
Yes, ma.
That is how it is. So the highest one here is 33. That is 5. Have you seen it? Followed
yes,
by
ma.
the second one is 15. You rank it as 4. Are you getting it?
Yes,
followed
ma.
by the next one is 12. You rank it as 3. The next one is 10. You rank it as 2. And the final one is 1. The final one is 5, which is 1.
1.
Then let's see the second ranking now. Because that is what this is first one and this is second one. Because I say you are comparing 2 things. You are ranking 2 things. That is what you use and determine to know whether it has a relationship. Let's now see the second item now. This one is the first item. This is the second item. The second item, 3, 17, 12, 8, and 12. Have you seen it now?
Oh.
This is ahead.
Yes, ma'am.
Then this one now, the highest here is what? 17, which is you rank it as 5.
5.
Are you getting it? Good.
Yes, ma'am.
The second one, have you seen that this occurred 2 times?
Yes, ma'am. 12, 12.
Good. Good. And it's supposed to be 4. Are you getting it? This is supposed to be 4. What will you do? You have to divide it because you have to divide it because you're supposed to rank 1. This one, 2, 3. Are you getting it? It means you are ranking 1, this one, and the other one will take the next one. Are you getting it? Hello?
Yes, ma'am. Yes, ma'am.
Yes, ma. Yes, ma.
Are you getting, see how they rank? The highest one is 5. Are you
Yes.
getting it?
Yes,
Do
ma.
you know this one's supposed to be this one's supposed to be 4, and you know it is
Yes,
2.
ma.
It means it will now be 3.5. This one also will be 3.5. You can't say 4, 4. Are you getting it?
Yes, ma.
When you add these two now, what will you give you?
7.
It will be 7.
8.
7. 3.5 plus
It will be
7.
7. That
Okay,
is why
5 of
you,
7 is 7.
it will be 7. You will divide it into 2 to get 3.5, 3.5. Because it occurred in 2 places. You can't say 4, 4. Are you getting it? And you know you already rank this one as 5. I didn't mean this one is only 1. It's supposed to be 4. Are you getting it?
Yes, ma.
And the next one is supposed to be 3. Are you getting it? But you
Yes,
can't do
ma.
it like that because it occurs in 2 places. So you have to reduce 1 and divide it. It's now be 3.5, 3.5. So the next one you will ranking is supposed to be now 2. Because you can't say 3 again. The one that's supposed to 3 has occupied it. Are you getting it? Then the next
Yes,
one
ma.
will now be 2. And the last one will be 1.
1.
Have you seen it? I just want to explain to you how to rank it. Anyone you see, the one that occurs 2 times or 3 times, you have to divide it. It will now be the same thing. Then the next one you are ranking, you now, maybe if it's up to 3 now, and this 8 followed also. If this one is supposed to be 3.5, 3.5, 3.5, the next one you are ranking is 1. Because you can't say 2 again. Because you say, if you say it, you won't get it. Have you seen it?
Yes, ma.
So, good. After the next thing, see what it means now. See what we do. The X, this is X, this is Y. Are you getting it? Okay, that one is just the one. But this is let's use this one and do the main ranking because this is just the beginning. This is another example that we use now. Let's use this one. It will help us to now solve the Spearman rank correlation. This is another question now. Let's use this question. Have you seen this question? This is X. S has 2.3, 2.7, 2.3, 2.5, 2.8, 2.3, 2, 2.3, 2. Have you seen that? 2.3 occurred
4 times.
1, 2. If 4 times. This means then after finding the difference, the next thing you do is to square the difference. So let's see what they did now. The first one, this thing. Let's say this is rank for X. Rank for X, the highest there is what? It is up to how many? 1, 2, 3, 4, 5, 6, 7, 8, 9.
9.
The number is 9. And the highest there is 2.9. The 2.9, you now rank it as what? 9.
9.
Have you seen? The followed
Yes,
one, the highest again is 2.8.
2.8.
You rank it as what? 8.
8.
The next one that is highest again is what? 2.7.
2.7.
You rank it at 7.
7.
Have you seen it? The next
Yes,
one
ma'am.
is what? 2.5.
2.5.
The 2.5, you rank it at 6. Have you seen it? So
Yes,
the next one is 2.3. Have you seen it? And 2.3
Yes,
is how
ma'am.
many there? Is 7, is 4.
4.
1, 2, 3, 4. What you do is you rank it 3.5, 3.5, 3.5, 3.5. Have you seen it? How many? That is 1, 2, 3, 4. Then the next one is what? Is 2.2. Have you seen it? The 2.2
Yes, ma'am.
will now be 1. Have you seen it? Do you know why it will be 1? Because all this one have occupied this thing. I didn't mean that it's only this one that is 2.3. you rank it as what? Get what I'm saying? Because the 5, you rank it as what? 5. Have you seen
5.
it? Then
Yes,
the
ma'am.
next one, this one is 2.1, 2.2. You are rank this one as 5. Are you getting it? Assuming this one is 2.1, 2.0, you rank it as 4. And this one maybe 2. You rank it as 2. Have you seen it? That is why this one will now be 1. Because it means that as all of them are the same, you will still rank everything 3.5, 3.5, 3.5. And the final one will now be 1. Because when you check it now, assuming this one 8, 9, 8, 7, 6. Have you seen it? 6. And you say 6. This one will be 5, 4. Have you seen it? 4, 3.
Yes, ma'am.
2.
2.
Then this is now 1. That is why it is 1. So anyone that it will call the same, you know, you use it 3.5, 3.5. Then the next ranking will be, maybe it is 2. If admin is 2 now, you said 3.5, 3.5. The next ranking will now be 3. The next one will be 2. The next one will be 1. But it, you know, it occurs in 4 places. It has occupied all the 3, 5, 4, 3, 2. It has occupied it. Then the final one will now be 1. So that you know that is the ranking. Then next rank the Y. Ranking the Y now. The highest there is what? The highest in Y is what?
27.
33 now is the highest for Y.
33.
Is 33. That is 9. Followed by which one?
Followed
by 27, which is 8. Followed by 26, which is 2, which is 6. Followed by 21, which is 5. Followed by, you have a question?
Yes.
What is the question?
Okay, I think I'm lost when you got to the ranking of X. I don't know how you got the 986, because from the first one you explained, you started ranking with 5, 4, 3, but either.
I said, let me explain. Don't say I started. Just understand. Once you understand something, when you are sleeping, you know it. I said the ranking is that the highest, we take the highest number. Are you getting it? It like that. When you start the highest, we take the highest number. Are you getting it?
Highest number. Is there no limit of the highest number? Because the first one you gave.
The limit is the number. Listen now. Okay. The limit, you first of all know how many it is. Like it is 1, 2, 3, 4, 5, 6, 7, 8, 9. You will know the number first. The number of this thing is 9. Are you seeing it? Yes, not that you will rank anything you want. You will first of all know N. N mean the number. Are you getting it?
Yes.
Okay, you are on that. Good. N meaning the number. It is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. You now know that it is 9 in number. You now check the highest. The highest, we take the highest number. You start ranking it like that. Are you getting it now?
Yes.
So I can continue.
Yes, please. Thank you so much.
Good. And welcome. Then ranking for Y. Now, you know we are now ranking Y. Y now, the highest in Y is 33. That is why it is taking 9. Are you getting it? Followed by 27, which is 8. Then another highest now is 26, which is 7. Followed by which one is highest? 22, which is 6. Followed by 21, which is 5. Followed by which one again? Followed by which one?
20.
And have you seen that 20 appear 2 times?
Yes.
Have you seen it? Good.
Yes.
And 20 is supposed to take, like, I mean, this one is 20 and 19. It's supposed to take 4 and 3, but it appears 2 times. You now use 3.5, 3.5. So the next one you're now ranking is what? 2. You can't say 3 again because it has taken the position of 3. Are you getting it? Okay.
Yes,
The
ma'am.
next 19 we now take 2. And the last one is 80, which we take 1. The next thing you now do is the D, which is the different from of rank X and rank Y, which means minusing it. 9 minus 9 will be 0. Are you getting it? Then you say 3.5 minus 6. You know 6 is greater than 3.5. That is why it's minus 2.5. 3.5 minus 2, which is 1.5. 1 minus 5, which is minus 4. 8 minus 8 is 0. 6 minus this is 2.5. 2.5. Then, are you getting it? Then 3.5 minus 3 is 0. This one is 0. This one is 2.5. Then you square the difference. When you square it, you get all these things. And remember the formula is 1 minus 6. 6 is constant. Summation of ds all over n. Minus 6, which is constant. When you add all these things now, summation of ds, you add everything. When you add everything, you get 37, which is 37. And you know our n is 9. Bracket 9 square minus this. So after solving this thing, you get r equals to 0.692. Have you seen that it is close to 1, is more than 0.5? It means it has a strong positive relationship. Have you seen it? It has a strong positive relationship. That's our IR now. So this thing is another formula, another example for rank, using rank correlation. Any question? That's another. It's all about the correlation. You read it very well. The first one we did is the product. This thing. The next one is this. And the next class will be networking. And when it will stop B. And when B starts, it will stop at, so that you will be more confused. I want you to read it very well. Read it, prepare this networking. Discussing, drawing this thing, what I'm saying. Just read it so that when I'm doing it, you where you lost, you get it. For correlation. Any question? Hello. Hello.
Hello, ma. We can hear you, ma.
Any question?
No, ma.
But it's dragging.
Hello. What I would say is that Madam's network needs to be improved.
I say you should read. I say you should read that networking very well. That do. I want
Hello?
people to read this. I can hear you say what?
So your network ought to be improved. It's very, very dragging. Sometimes we don't hear what you are saying. Keep on, throwing us off balance. And it's from your end. We can hear each other on the other way, the participant. You sometimes it will just go off. So I think you need to look at the bandwidth of the network you are using. Maybe you need to increase
So
what you are
all
using.
the thing, okay, all the thing I'm saying, you didn't hear it at all.
We do hear you. As you are speaking now, you know that your voice is dragging. I don't think if any person is hearing what I'm saying.
It's true, it's dragging most
Maybe
times.
it's the area I am. So, may not that one is beyond me. So you couldn't hear what I've been saying since.
No, we got what you were saying, ma, but it was a little draggy. Like we didn't hear exactly certain points. And towards the end of the class, it was actually worse. It was dragging seriously.
But at least you get some things I said.
Yes, ma, definitely.
Okay, just read it. Read that correlation very well. At least the two things I did in correlation is Pearson product moment correlation, which we did. And I tell you how to get the test statistics and everything. Then the second one is the Spearman rank correlation, which I explained. When you go, just read it very well. And I said the next class will be networking. And I want you people to read that networking very well, so that when I start talking, you won't be confused. Did you hear that one I said?
Yes, ma.
Yes, ma.
Okay. Okay. Let me leave you people. I think I will leave you people. I pray that next class, the next one will not crack.
Amen.
Amen.
And good night. Just read everything I say so that you understand.
There will be
Good
improvement
night.
next time.
Even you, your
All right,
sounds
man.
like
Good night.
Good night, ma.
Hello, Engineer Helmai. Can you hear me? Hello, sir. Good evening.
Hello? Yeah, good evening.
Yeah, it seems our network, the area where she is at Unsuka, the network service provider that she's using is not too strong there.
Yeah.
Although we are trying to conduct
Where are you
analysis.
Where are you
for her.
talking to me from?
I'm presently
Hello?
not in Unsuka presently.
Where are you? Sorry. So
I'm in Abuja presently.
Okay. You are very clear.
Sir?
I think you are very clear. Your audio is very clear.
Yeah, that's what I'm trying to explain. It seems where she is, the network service provider that she's using is not, the network is not, servicing is not so strong there.
Okay.
So we are trying to do a network analysis to come up with the best solution going forward.
It's an observation now, which I think every other guys must have. Because at a point where you're supposed to pick up something, you'll be locked out entirely. It looks somehow. We do experience it with respect to other lecturers as well. But her own is a bit, let's say, is a bit more disturbing than others.
Yeah.
It's just an observation. I do understand what
I'm using mine now.
Yeah, we apologize for that. We are looking for a way to improve on it presently. It's also an issue for us. Sorry about that, sir.
No problem. Like where I am now, I used to use MTN, but I found out that Airtel is better. So I have to switch over to Airtel, which is far better than. All those, as you rightly said, let us do it so that we enjoy what we are doing.
Yes,
very well.
that's the essence. That's the idea. We'll look
All
for
right,
it.
I appreciate so
Thank
much.
you so much, sir.
All right, well done, boss.
Have a
Good
good
night.
night.
How you too.
Is it working?